We're going to learn what a tensile test is. A tensile test is a fundamental test in material mechanics. It's performed by pulling a sample of material apart until failure, while measuring the force and displacement. It provides us with something called a stress-strain curve, which tells us a lot about the material's reactions to forces. In this scenario, the stress is defined by the force applied to the test sample, divided by the cross-sectional area. This gives us units of newtons per meter squared, which you may recognize as the metric unit for pressure, pascals. Stress goes on the y-axis. Strain describes how much deformation has occurred with that applied force, and it is found by dividing the change in length by the original length. This is placed on the x-axis. Let's watch this test again, and see what information we can get from the stress-strain graph. As the stress rises, the material begins to deform. This initial linear region is elastic deformation. That means if we remove the force, the material will regain its original shape. Think of how a rubber band can deform hugely and still come back to its original shape. The end of this linear elastic deformation is marked by the yield point. From here out, any additional stress will cause permanent deformation. This is called plastic deformation. The stress continues to rise until it hits the ultimate tensile strength point. This is the ultimate strength of the material, the most stress it can handle. From here, less stress is needed as the material begins to decrease in cross-section, which you can see happening here. This is called necking. This continues until the material fractures. We can get a lot of really useful information from this graph. The first is Young's modulus, otherwise known as the elastic modulus. This describes how stiff the material is, and it is obtained by finding the slope of this linear region. A steeper slope means a stiffer material. For example, a high carbon steel may look like this, whereas a flexible material with a low Young's modulus, like rubber, would look like this. This graph is not to scale, but it should give you an idea of how this information is represented. Young's modulus is one of the most used properties in engineering, as we can use it to predict deflection in a huge range of scenarios. Yield strength and ultimate tensile strength are two other important properties. An engineer will divide the yield, or ultimate strength, by the safety factor to achieve the max allowable stress, which is used to influence the design of the product. Usually engineers will aim to keep the max possible stress well below failure, but safety factors differ between industries. So we've seen a stiff material and a flexible material. Now let's look at a material in between. This material can be described as tough and ductile. Tough simply means the material can absorb a lot of energy without breaking. The area under the graph here defines how much energy is absorbed. Ductile means it deforms under pressure. The two previous materials could also be considered ductile. Spring steel is a tough and ductile material with a high yield strength, which is why it is used in springs. Springs need to absorb energy without permanently deforming. The opposite of ductile is brittle. A brittle material is a material that breaks with very little deformation. Glass, ceramics, and cast iron all fall into this category. You can actually tell if a material is brittle or ductile by examining the fracture surface after they have broken. A ductile material will have this characteristic cup and cone fracture surface, whereas brittle fractures have granular, flat-looking fracture surfaces. Some materials can go from ductile to brittle when their temperatures are lowered. This was actually a massive problem during World War II with the Liberty ship. Several of these ships literally broke in half with no warning, including the SS John P. Gaines, which broke in half in the frigid waters of the Bering Sea. It was later discovered that the grade of steel being used became brittle at lower temperatures. This problem was made worse by the stress concentration at the hatches, which you learned about in my first video, Why Are Plane Windows Round? This embrittlement is also thought to have contributed to the fracture of the Titanic's hull. The final material property I want to talk about is hardness. It is directly related to the stiffness and yield strength of the material, but it is used to describe how difficult it is to dent, scratch and abrade materials. One way this material property is measured is with the Rockwell hardness test. This test involves 3 steps. First, a minor load is applied to the material by an indenter. This establishes a 0 point. For the second step, a major load is then added, which indents the material. And for the final step, the major load is removed while maintaining the initial load. The difference in depth between the first and third step is then used to calculate the hardness of the material. Diamond is a very hard material, which is why it is used in cutting tools. One of the fantastic properties of steel is its ability to be heat treated, to have its hardness tailored in different areas. For example, with swords you want your cutting edge to be hard, but the core of the blade to be ductile. This means the sword can bend under pressure without breaking, while the cutting edge can resist damage. As always, thanks for watching. I wouldn't have the opportunity to make videos like this without sponsors like Lumerit. Lumerit is a new way to get college done quickly, from the university or college you choose for a lot less money. I was lucky enough to get an education in Ireland for pretty much free, but this is not a luxury many people have. In the US, the cost of getting a higher degree from a university is prohibitively expensive. And the Lumerit Scholar program is out to change that. Whether you're aspiring to go to college or you're already there, Lumerit can allow you to complete up to 3 years of college for $4,000 or less per year, and allow you to take classes from anywhere in the world. So how does it work? A Lumerit counsellor will help you plan out your college path, getting credits from schools that are guaranteed to transfer to your target school. Go to lumeritscholar.com/real-engineering to see how much you can save with Lumerit Scholar. They will email you and give you a personalised consultation to help you save thousands on your education.